Hello friends, today we will discuss projection matrix. What is projection matrix? Projection matrix is which follows this property p square is equals to p. When we take square of the matrix, then it is always itself. Then it is called projection matrix, right? Projection matrix, let us define example of this 0.5, 0.5, 0.5, 0.5. That is the projection matrix. Find out the lambdas. What is the lambdas equals to? It is the eigenvalues are which we will find out by taking the characteristic equation p minus lambda equals to 0. This will lambda equals to 1 and lambda equals to 0. Firstly, when we take lambda equals to 0, then it will give p minus lambda I. So it will give the p minus lambda I x. Then it will give x. For finding x, we will have to find out x, right? Then it is when lambda equals to 0, then it will 1 minus 1, right? Because x1 is 1 and minus 1, which will gives you 0, right? This is give to you 0. So x is 1 and minus 1. First eigenvector is this, and second eigenvector we will take for 1 minus, when we take p minus lambda I, so it will give 0.5 minus 1. This will minus of 0.5. This will also minus of 0.5. So it will always take, we will take v1 and 1 and 1. So it will give 0, right? So though there are two eigenvector, x1 is equals to 1 comma 1 and x2 is equals to 1 comma minus 1. So the first stage is that for lambda equals to 1, lambda, when we put lambda equals to 1, this will implies px1, it will goes inside. This will give p x1 equals to x1, right? For lambda equals to 1, this is x1, this is lambda 1 and this is lambda 2. For lambda equals to 2, it is x2. So this will give whole null space, right? This is state to a steady state, and this will give null space of this projection matrix. Now each column of p adds to 1, so lambda equals to each column of p gives you 1, right? When you add it, this will give 1. And when p is singular matrix, because each row is equal, r1 is equals to r2, so this is singular matrix. So lambda equals to 0 is an eigenvalue. So we will find out this way too. P is symmetric, so its eigenvectors 1 1 comma 1 1 comma minus 1 are. Projection matrix are eigenvalues are 0 and 1. Lambda equals to 0, fill the null space. Lambda equals to 1, the fill up the column space. So the projection keeps the column space and destroys the null space. Projection, what projection gives? Projection gives the column space and destroys